Welcome to section 15. In this section, we're going to be learning about arrays and vectors. We're also going to jump into section 16 because there is more detail on arrays in section 16. So by the time we complete this section, you should be comfortable with and familiar with arrays, 1, 2, and n-dimensional arrays, how to create multiple or parallel arrays. And then finally, we're going to talk specifically about character arrays and something in C++ called C-strings. Then we're going to be going over vectors and finally see if we can determine the similarities and the differences between arrays and vectors. So how about if we start with arrays? Here's an example of an array declaration. We need some kind of a data type with the name of the array and then the square brackets with an integer value for the size of the array. Now we can see that arrays will all store like data type values. So this particular one, the time array, is all going to be integers. They are stored sequentially in memory, which makes it really easy to use looping structures to move through the elements of the array. We're going to see that an array, that name of the array, is actually a constant pointer to the first element. We call it the base address of the array. The index 0 to 5, so it is 0 based and not starting at 1. So arrays are very easy to loop through. Now, you don't have to actually indicate the size of an array. You can implicitly, if this is explicitly setting the size of an array, you can also implicitly set the size of an array just by initializing it to a comma-separated list of values. And then the number of comma-separated values would be the size of the array. And this is because the size of an array is static. When it is created, that is the size of the array. It cannot expand and it cannot contract. So let's look at a two-dimensional array. Here's an example of a declaration for a two-dimensional array. You notice the only difference between this is now there are going to be two sizes. I might call them rows and columns. For example, our checkerboard here, rows and columns. And so you can see a declaration for our tic-tac-toe board. We have a two-dimensional array. They are comma-separated list of braces. And so now I'm going to have 3 rows. I laid them out so that you can see the 3 rows. And there are 3 elements in each one of the row. So here's an example of a 3-dimensional array, like a Rubik's Cube. This is actually a mini cube that I found. And it is a 2 by 2 by 2. And I'm going to say that now we're going to need 3 integer values for its size. The number of rows, the number of columns, and in our Rubik's Cube, we are going to have depth. So this is what it might look like if I were to implicitly, instead of explicitly, set the size of the array. Notice that I am going to have comma-separated groups of braces. This time I have 2 rows, so you can see the 2 rows. There are 2 columns per row, and then in each one of those columns there are 2 values. So we can either implicitly or explicitly set the size of an array. And then I tried to find an n-dimensional array. This would actually be 4-dimensional. So if a 3D array is just an array of 2-dimensional arrays, then a 4D array would be an array of 3D arrays, and so on and so forth. So this would be the declaration for this. There is 3 rows, 4 columns in each row. There are 3 in depth on our 3-dimensional array, and then I can see on our 4-dimensional array there are actually 4 of them. So let's see if we can determine some of the methods that are available to an array function. Now, some of the most useful methods are listed on the left, and then there is a more comprehensive list and the link behind the more methods on the right. Some of the useful methods to be able to determine the size of an array, how many elements there are, to be able to access elements at a specific index. We see that there's 2 different ways that we can do that, using the .at function and then using the operator index function. Both of those are 2 different ways, and there is a difference between the 2 of them. The front and the back methods obviously give us the first and the last element of the array. All right, how about if we look specifically at an array of characters? a char array. This is a standard example of a char array. So the data type is char. I'm going to give it a name. I'm going to say that there's 20 elements in it. We'll initialize it to 20, and then I'm going to do comma separated values, and this is what we will have. So originally there were no string objects in C++. Strings were just an array of characters. And so the next thing that they invented, or the next thing that came out, was a C string, or a character string. It is just a null terminated character array. So if you'll notice, the declaration of this C string has the data type, and then I give it a name, a variable name, with 20 characters in there. But this time, instead of comma separated values, I can just surround the whole thing by double quotes, and a C string is going to be null terminated. And that is in comparison to a string. In C++ now, modern versions of C++, there is a string library that has a variety of different methods available to it. And so this is an example. We would have to #include string in order to be able to bring in that library. But then I'm going to initialize it the same way that I would a normal C string. Notice how it is not null terminated. So it doesn't contain the null terminator or the /0. We don't have to worry about memory management. It is a string object of the string class, and we have to import the library to be able to implement that. And there are functions that are available to strings. The character array, or the C string is null terminated. If it's allocated on the stack, the memory management, the memory remains fixed. If we allocate it on the heap, we have to manually manage the memory of a C string. We can directly implement and represent them as arrays, and it is a natural part of the language, so I don't have to import anything in order to use C strings. So let's look at some of the different methods or functions that are available to the three. So I found a short list of methods available to chars on the far left. That was in section 15.5. In the middle, in section 15.4, you see some of the examples of methods that are available to C strings. And then on the right, in section 316, and the link to that, there's a link in that name, is a much more comprehensive list from C++.com, showing you a variety of the different functions that are available to strings.